installed in the place of those 2.01 disc caps. Okay. Same capacitance. Let's give the Deluxe Reverb amp an inspection. Front panel looks good. Control knobs are in excellent condition, not all chipped up. And the panel's fairly clean. Usually these things come in here pretty grubby. There's a little bit of a buckle right here on the front panel. I should be able to straighten that out. Let's take a look inside. Got some corrosion on the back edge. Maybe something got spilt in there at one time. Don't know. Screen resistors have been replaced. It's got the grounded type power plug, but it looks like part of the old restraint is still there. It's kind of odd. It's got a zip tie, I believe, holding it in place. Some of the caps on the Eyelet board have been changed. It still has what I call the little ceramic disc microphones. Let's see if we can get some sound out of this one. Oh yeah. So imagine you're playing your amp and internally this guy's going, you could probably hear it. And it's got those old red chocolate drop caps, I think that's what people are calling them. Those all need to come out. Let's flip it around and look at it at a different angle. Alright, let's start on this end. We'll make our way across. Looks like all the controls are original. It's a good thing. There are some questionable connections here on the board, but nothing really alarming. Everything looks pretty much original on the controls. That's a good thing. It appears as though somebody's been playing around a little bit with the bias pot. And over here is your bias, your negative bias rectification with the cap. And it looks like somebody's added a resistor in line, so maybe they're having some bias issues. But if you take a look down here, maybe this is the cause of most of the bias issues. This is the ground connection. It appears as though somebody tried to solder it to this transformer lug, and it's loose. So if you think about your negative bias that's trying to hold your output tubes at a constant current and you're losing your ground, I bet you that this thing was really running hot because the negative bias was probably intermittent. So the amp came in with a complaint of low volume on the vibrato channel only. Normal channel appears to be okay, but before I think about putting tubes in this thing, I have to fix this negative bias power supply and make sure that's functioning so I don't smoke the amp. So a quick look, top side. Appears though we have the original iron in the amp. Tube sockets all look good. Have the filter caps been changed? Yes, they have. So that saves me a lot of work. Alright, let's go down there, fix the negative bias power supply, get some tubes in it, and see what we get out of it. So I fixed that ground wire on the negative bias power supply. So right now I have all the tubes removed. I'm just going to power it up. Make sure we have the negative voltage, and we do, so that's a good sign. Let's go ahead and get the tubes installed and give it an initial test. Alright, so the amp is fired up, monitoring the output on a scope through my audio test set using an audio generator as an input. So let's see what we got for channel 1. Looks good, plenty of power. Let's see if the tone controls are working. Yep, good deal. Alright, let's go to the vibrato channel. Now I'm in the vibrato channel. Let's see what we got on the scope. Same deal. Bring up the volume. I got nothing. No output. So yep, we got a problem on that channel. Let's see what it is. So let's just do some quick signal tracing with the oscilloscope on the vibrato channel. Alright, so I got 2 cameras going so you guys can see what's happening. There's my input signal from the AF generator, and from there it's we come up to the volume control. Okay, so there it is, little gain coming off of the 12AX7. Then we go to the middle terminal of the volume control, and when I turn that up and down, oh look, now I've got output. Well, that's strange. So I wonder, I'll reach under here and play with the 12AX7. Huh. Got signal now. So now I wonder, do we have a bad solder connection on that 12AX7? Because I had no output at first, and we got it now. All kinds of output. That would lead me to believe we have a bad solder connection. What about my favorite diving board caps here? Nope. They're not cutting out. Alright, I'm going to kill it and inspect that tube socket. Alright, all the connections underneath look good. I'm not a big fan of just taking leads and pushing them through the tube sockets and soldering them, but Fender's done it forever. They seem to hold up. Alright, I guess I need to take a look on the top and see if there's any deformed tube pins, socket pins that is. Well, there it is. Take a look at these 4 sockets and these 4, but then look at this guy right here. It's spread apart. That is one of the filament pins, okay? So if that guy was intermittent, your filaments would probably go to about half of what they should be, because pins 4 and 5 are tied together. So my guess is that is the one that's causing all the issues. So I'm going to reform that contact, put some deoxit in there. We'll retest. Alright, retest time. Clean that socket. Now look at her. Go down here and rock this tube around. Looks stable as can be. That's all it was. Well, we can't stop there, can we? So the next thing that needs to happen is recap this eyelet board and get some of these drifty 100K resistors out of here, put in some metal films, because these are known for generating noise. Okay. Also noticed this speaker output jack is all sprung out of shape. Something obviously happened to that poor guy. So let's recap it, inspect it, make sure everything's sound, and retest. We'll get the recapping underway, and for the task I have elected to use these Mallory coupling caps. Okay, this is the M150 series. I buy them in bulk. So here's 0.1s, 0.047s, and 0.022s. Okay, that's what I'm going to put across this eyelet board. These are not the off-brand ones that you see on eBay that don't have any identification, so don't confuse that. Alright, so changing these caps. It's a piece of cake. It's kind of like pulling teeth. Okay, just grab the lead, get your iron in there, wait to see that solder move. Grab the lead and pull it out. If you have your pliers on the lead while you're trying to do that, it's going to heat sink it and you're never going to get the cap off. Okay? Just wait until you see the solder move first. Of course, keep these wires out of your way so you don't do a meltdown. There it is. And take your new cap. I always put my little bend in there first. I trim it after I install it, so I can get the length exactly where I want it. Of course, this coax is going to fight me. You want to be really nice to these wires, guys, because the wiring is brittle. Alright, so I finally got the lead to go in. This cap was in my way. That lead was fighting me. So now I've got that guy in place. Get him to drop into this other eyelet. Then we can move on to that .047 that was playing games with me. Sorry if my hand's getting in the way, guys. Trying to give you what you asked for. I understand you guys want to see it as it happens, and I'm doing my best. Alright. Now, I'm going to reflow these solder connections after I get all the parts in, okay? So right now, I'm just going for alignment on the leads. I got the second cap in place. Bend him right around there. This is the way that I found that you could get a neater job is not to pre-cut your leads. If you do it this way, you're kind of guaranteed to get proper alignment without having big loops of leads hanging out or having them too short. That would suck, wouldn't it? So you get them in place. Don't worry much about the solder connections at this point, okay? We're just going to go for alignment. So now I want to get these guys out of here. We're just going to keep going across. Alright, get that coax out of my way. Now we're going to pull out the first 100K resistor. Okay? Same deal, heat up the eyelet. Wait to see the solder move. If it doesn't move, give it a little more solder. That'll help transfer the heat. There she goes. Now, I'm going to be replacing these resistors with these little half-watt 5% type versus this big 1-watt 10% 100K. These 12AX7s don't pull a watt of power. I don't know why Fender used these. Maybe they got a good deal on them, but you don't need them. Okay, so we're going to put in these nice metal film resistors in the place, and it'll look a lot nicer when we're done. Alright, first side's in place. Bend this one to line up. Now you're probably asking yourself, why don't you just pull all those parts out of there, Terry, and rebuild it? Well, I believe in leaving yourself a roadmap. Okay? So if you got in here and you just pulled everything out, and then you put it together and you mess up on one component, it leads to a lot of unnecessary troubleshooting. So even though I've done hundreds of these things, I still do it this way. Because you know what? D-Lab ain't getting any younger. Look at here, I can't even get this stupid eyelet thing to let that lead in. Same problem as before, so I'm going to lift this other 100K out of my way. And the other advantage, of course, by getting these big pigs out of here, is now you got a lot more room in the eyelet, because these little guys here, it's about 1/4 the size of that lead. I hope you're enjoying this overhead view. You guys would laugh if you saw how I was holding that camera. Maybe I'll pan out to that later. I've actually got it on a little push-up monopole. It's jammed up underneath my shortwave receiver. Holds it, does the job. Alright. Alright. So I'll land these two guys and then we'll move on to this cap here, which is a .047. I got all of our 100Ks in place. Let's get this .047 out of here. Here's my new one. So you can see once you get going on this, it'll go rather quick. Alright, so here's that next .047. The whole process gets quicker and quicker, obviously the more you do. So now I'm going to go through, clean up these connections. Oops, it got popped up on me. Back in there you go. I got something I want to point out to you. I'm going to change these two disc caps. These are .01 disc capacitors, and there's actually two of them wired in parallel. So they're going to come out, and I'm going to replace them with one .022 microfarad cap. Once again, I don't know why Fender used these caps. Normally you see disc caps like in RF circuitry, okay? Some ham guy would probably love to have this thing in his transmitter, but for a guitar amp with the vibrations that you have with audio, these guys kind of sit there and bang together. And some of my earlier videos, I would tap on these and you could watch it on the scope. So they're like little diaphragms. They're like little microphones. They don't belong in these amps. There's the new .022 microfarad cap, which is replacing the two .01 ceramic discs. You can still see we have the smaller ones in place for the treble circuits. These do not cause the problems that these big guys do. It's probably because this has a much bigger diaphragm and is much more susceptible to vibration. So I'll be leaving those in place. Alright, now I'm moving into the tremolo circuit. You can see we got those .01 microfarad disc caps again. But what I use in this area is not audio grade caps like the Mallory's, okay? I use these little Panasonic type caps. Since this is nothing more than an oscillator, you don't need to install big Sprague orange drops. You're wasting your time. You can get these for about 20 cents a piece. They do a great job. And they take up much less room. Alright, there's the first little cap that changes out these dual .01s. Now I'm going to pull out these .01s and put these little guys in their place. So you can see the new caps take up much less real estate. I've seen people try to cram those big Sprague orange drops in here. It's just not worth the effort, guys. So I was getting the amp ready for final checkout, and the whole time that I've been working on this thing, I've been hearing this funny pop. It's kind of like a mechanical pop, and it only happened when I initially turned on the power switch. Standby is off, right? So no high voltage applied. As soon as I turned on to hear this little pop, then everything was fine. The amp would play fine. I could tap on it all day long. No sensitivity. And it did it again to me when I was getting ready to put it together. And I was like, man, I've got to figure out what this is. So I killed all the lights in the shop, and I would work that power switch, and I'd hear the little pop, pop. But there was no signs of arcing anywhere. I thought, well, that is really weird. And then it occurred to me, even when you turn on the filament switch, the high voltage is on, but it's only on in the high voltage cage, right? The cover over the filter caps. It's sitting there waiting for you to turn on that standby switch. So I thought, you know what, I better take a peek under that cover. And I did, and here's what I found. So I removed the cover, and the first thing I spotted was these 3 wires. And they were laying along the chassis on the side of this insulated board, okay? So they're in contact with this cover inner wall. So I looked and I did see some little brown marks on the steel where it had been arcing. So probably what was going on is when you initially turn on the amp and it's unloaded, that high voltage goes pretty high and it probably exceeds the insulated breakdown of this wire. And since it was so close to this cabinet, it arced, okay? And then it would stop obviously when you turn on your high voltage and the level goes down. So what I did is I added an insulator on this edge. I've marked the chassis, and there's the other dot, so that's the way it's going to go. I also brought the wire up away from the metal, so that should eliminate the problem. Let's get it back together and test it. Alright, here we go, test time. I did repair that AC line cord input, cleaned that up and got the restraint installed. I also added a current shunt so I could watch the current through the output tubes. We're hooked up to the audio test set, audio generator, and the scope's over here. I'll bring her up. You see we have wattage, and it's nice and clean. And that was the dead channel. So all's well with the Deluxe Reverb amp. Time for me to get this thing boxed up, move it out of here because there's more in line. Alright, so what a great repair that was, and a lesson learned. It came in here with that low volume on the vibrato channel, which turned out to be a pretty straightforward repair. But if I had stopped there and kicked it out the door, I never would have caught the old popping cap cage, which would eventually damage the amp and I'd have one unhappy customer. So that's why I take my time, I try to do it right. It's my reputation. See you again.